Hello there. Good afternoon. It is Friday, November 1st, and I am Rob. Around here, I'm that developer dad. And rather than dig into starting to create the functionality for this admin subsystem I'm creating for the DM's familiar, I think I want to spend some time hacking on some concepts around how components within this system are going to obtain instances of their dependency components and how those components are actually going to talk to each other. So we're going to dig deep into maybe creating sort of a very simple, simple is a bit of a misnomer, but an application framework that allows us to construct a modular monolith with, the various components for the system all coexisting beside each other, but at the same time being nicely isolated from each other and so on. The .NET dependency injection that got introduced with .NET Core, in particular ASP.NET Core, but we also have like the I-hosted service concept for like a background worker and so on and so forth. Those are all really, really great, but we're still passing at the bottom line. We're still, when we inject using those hosted services, we're injecting the actual instances into our component classes, and by registering everything at program.cs, it creates the potential for a bit of a Wild West scenario where a new developer could join the team and they don't understand the concepts of the closed architecture and everything like that. So they start injecting dependencies into services that shouldn't have those dependencies and so on. And your nicely decoupled modular monolith suddenly becomes a very tightly coupled mess that becomes incredibly hard to maintain and make changes to in the future. And hiring developers takes a really, really long time, and bringing developers up to speed and onboarding can be incredibly painful and incredibly expensive. So I want to build out this system that uses this closed architectural concept that I've been talking about for the past few months. But I want to try and wrap as much of an easy button around it as I possibly can, so that we're able to maintain, or so that we're able to preserve and protect the maintainability, extensibility, security aspects, all of these non-functional requirements that any production level software system should have, without the frontline developers really having to worry about the guts of how their components are being spun up. A lot of these concepts, like especially around this closed architecture, run counter to what people have gotten used to by using the dependency injection that Microsoft has given us. And it's a great system if you're building something relatively small or not terribly complex, because you don't have those worries of cross-contamination between your managers that kind of encapsulate your vertical slices within your domain. So I want to see about a slightly different spin on how we do this. Now, for component to component with DI, typically we'll code to interfaces, and we're going to keep doing that. And we'll inject an instance or an implementation of that interface into, say, our manager class. It'll get implementations of the engine and any engines and any resource access classes that it may need to to create the features that we're after. I would much rather inject instructions about how my manager could create a proxy to those services. Now, those services could be running in the same compute process as the manager, or they could be running in a discrete remote web service that we would communicate with via HTTP or gRPC or even message queues or what have you. And this is going to be a bit of a task. So let's review what I did this morning. And I'm going to get rid of this service factory because it's going away. And the customer account manager, it's approximately what we're looking for. Now, account manager, I need to go to the definition on this guy. And my account manager assembly or project needs a project reference. Oh, I do that like so. So we're going to add a project reference to dev.sasadmin.ifx. Okay. And iAccount Manager is going to inherit from iManager service. And we'll bring in that namespace. Okay. So now our iAccount Manager has become an implementation of iManager service. And I've just got like all that nice, tidy or untidy information about what a manager service is. Not in love with the return tuple there, but we can grind that stuff out as we go. So our manager service, or our customer account manager, it's internal, and it implements iAccount Manager. So I'm going to create this concept of a service factory inside the account manager. Now our iService factory is going to have of T, where T descends from class. Now, where T is iService. And we'll bring in our reference. Create service, T on the generic type or method. There is no boxing conversion or type parameter conversion from T to iService. Now, what if I remove the generic on iService factory? Where T implements iService. There we go. Now, let's come back to service factory. And it's going to be create proxy. This is going to implement service factory. I don't want emojis. Let's implement that interface. Come on, Rob. Okay, so that's not giving me quite what I want here. Excuse me. So I think what I need to do is instead of this being a public interface, it's going to become a abstract class. I'm going to rename this from iService Proxy to just plain old ordinary service proxy. Yes. And let's do I want to preface that with an underscore? No. Protected T implementation protected service proxy. It's going to accept an instance of T implementation, and implementation equals implementation. And I think instead of implementation, I want to rename that to service. Yeah, that'll work. Now, public abstract class in proc service proxy of T inherits service proxy of T in the generic type or method service proxy T, where T is an iService, save that, And we need to generate the constructor. Boop. And let's fix our formatting. Nope, that's fine. In proc service proxy. Why is the robot... Oh, the robot must be looking at ghosts. So in proc service proxy, implementation, cool, groovy. And public abstract class HTTP service proxy of T inherits service proxy of T where T I service proxy. Nope, just I service. Fix the formatting. Generate the constructor. Goes to here. Now. We're going to come back to this guy. I'm not going to do more work on HTTP service proxy yet. In fact, this child class will get implemented later. TM. Let's come out home. And we are going to comment that guy out. Save. Now, our service factory. Our account manager is going to define what a proxy to account manager should look like. Is it? Of T. Create service. No. Thinking. Let's save all here. iService Factory. Don't know that I love this concept here. Excuse me. So we've got these abstract proxies, right? Now we need to create concrete instances or concrete definitions of these proxies. So this should be defined. So that actually, let's uncomment this so that we can kind of demonstrate the thought process here. So the T implementation is actually going to be a typed HTTP client. Of T. Let's see if that's legal. Var client equals new HTTP client of T. No. Let's haul up, not Visual Studio Code. That needs to go away. That's for something else I'm working on in parallel to this. Tell me about typed HTTP clients. I'm pretty sure I can declare an HTTP client of T where T is some interface. Can't I? All right, so I've got my iMyService client. It does a thing. It's got an HTTP client, it accepts the HTTP client, and then we register the typed HTTP client as client.base address, new URI, blah, 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 additional configuration. And then my component, it receives that HTTP client. Good. Nope. Okay, so this proxy idea that I have isn't really super necessary for HTTP services. But I want to keep this concept in play here. Base implementation. Yeah. Let's just close this. Don't save. So service proxy of T creates service where T is iService. Now, this is going to be a bit of a convention. But we're going to create a new class inside the account manager, and it may not live there forever, so bear with me. Account manager proxy. In proc. We'll do that. And it inherits from in proc service proxy of I account manager. And implements I account manager. Now, I'm going to pull these guys down onto their own lines. There we go. Let's implement. And what are you complaining about? Parameter implementation. So we need to take in an implementation of iAccount Manager, right? Save that. And this is just going to throw a whole bunch of not implementeds. But in actuality, all this is going to do, in the simplest form, return and return dot store customer profile. All right. Now we can come back out to our service factory. Come out to the end here. Private I account manager configure service here's where we build the instance of the account manager equals new, and I'm going to call it the customer account manager. All right. Return service. var proxy equals new account manager in proc. And we're going to need to pass it that service. Equals configure service. We're going to pass that instance in. Return proxy. And it doesn't like that because proxy is not null, cannot implicitly convert that to a service proxy of T. I, account manager, and then I can get rid of this maybe. No, it doesn't like that. However, if instead of doing it returns a service proxy of T, I say it returns T. Save that. Come back over here. And say I, account manager, oh, it doesn't like that at all. What if I move the generic up here? So it returns just this. Come back up here. I, account manager, create service. It's created a new customer account service, and it's returning a proxy of our account manager as an in-proc proxy. And what does this actually accomplish for us? Configure the service here. And what we can do here is we can come back over to the customer account manager. Ha ha ha. And on this customer account manager, we can say well, we need to get around to our dependency manipulations, don't we? So let's save everything. And in the tests, let's add a new project. I'm just going to add a console app. I'm just going to call it test console. And we're going to add it to tests. Yeah, that's fine. Next. Do not use top-level statements. Yes. Go ahead and create it. So, internal class program, blah, 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 blah. We need to add a project reference to our account manager and SaaS admin. Okay. Now, let's come out to the end of this. Now, on the service factory, just for laughs, can I make that into a static class? It does not, because it's static. I'm going to take this service factory down here, rename it to account manager factory. Yes. Save that. Come out to program, and we're going to have static account manager. Bring in that reference. Get account manager. And we don't have any dependencies or any configuration or anything like that yet. But we are going to have a var factory equals new account manager factory. Cool, cool. And we're going to return factory dot create service. Var account manager equals get account manager. And excuse me, up inside customer account manager, just for now. Right line. Load or create customer profile. And we're going to do the same thing here. Just fakesy. Return. Null. Just for now. Right line. Manage customer subscription. Return null and null. Right line. Store customer profile. Out to the end. Return null and null. Save that stuff. Save. Come back out to program. And let's just do account manager dot load or create customer profile, new customer profile request. And yeah, that's something I don't like doing, is invoking constructors and stuff inside a parameter list. But we're trying to get something executable quickly. So I'm gonna break my own rules. And let's see if this will do what we want it to do. Save all. We'll set our console as our startup project. And we're going to step through. All right, let's step in here. We're going to get a new account manager factory. There's not really anything in that constructor yet. So let's step in. We're going to configure the service. And remember, all of this is happening within the context of the account manager assembly, not happening out inside the context of our actual program assembly. So we've got a new customer account manager service, and we're going to return that. And we're going to pass the instance into our account manager in process. So we're really just wrapping it in a proxy. Stop it! My cat is being silly. One of the cats is being silly. And now, even though we're dealing with a proxy, and I should probably change the name of that thing to an in-proc proxy, or local proxy or something like that. But now, see, we step into the account manager in proc. And then we're executing the method on the service and coming back out to our invoker. So what's the point of all that nonsense? And see, it wrote that stuff out to the console, just like we expected it to. So what's the point of building this 10-story outhouse? Well, because we've got this proxy, we can do some very, very interesting things. So let's see here. on the, not the service factory, or on the actual account manager thing itself, or its factory, or even necessarily this proxy. Customer account manager, not so worried about that. What about the new class or method interceptors introduced with .NET 8? So this, let's say this is just by illustration. We've got this interceptable method, right? Public static void, interceptor method, this CC int param, and then new C.interceptable method. And then a compile time substitution. Existing code by adding new code at compile time, which can be useful for scenarios like logging, validation, or modifying method behavior without altering the original code. Blah, 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 blah. So one of my proxy classes would be a good place to register interceptors and have those interceptors run in a pipeline fashion. So we've got this INterceptor that runs before invoke, after invoke. And then we've got our interceptor pipeline. And then for each interceptor and interceptors, target method name args. After invoke, target method name args. So we've got our service instance, our interceptor pipeline, our service proxy that accepts that stuff. And then we run pipeline before invoke. var result equals function. We invoke the function. And there we go. So that's sort of like our service proxy thingy. And then service proxy of T, where T is class. And what the heck is this? You can let me look at it. It's an iService, not quite. So register services and interceptors, blah, blah, blah. Class startup. Configure. One last thing. In proc service proxy of T is abstract. in my services assemblies, I declare a concrete proxy type for each service and return that from that services factory. So the proxies actually implement the service contracts as pass-throughs to the internal concrete service implementation. Concrete proxy types for each service. Yeah. So there's that. All good, right? So my service inherits from my service. It does work. Here's all this stuff. My service proxy does all this stuff. The factory for creating the proxies. So where in all that would we take advantage of the interceptor pipeline concept we just discussed? So the abstract proxy class gets an interceptor pipeline. So we create concrete proxy types using that interceptor pipeline. Okay. Register that pipeline and proxies, blah, blah, blah. So this is okay. This is all right. I think, though, it would be more valuable so we've got these interceptor pipeline. Where's the interceptor pipeline configured? Blah, blah, blah. Configure services. Interceptor. Yada, yada, yada. T call. Application builder, so on, so forth, all this stuff. Neither here nor there. Screw it. I'm not going to chase that right now. But there are ways that we can construct interception pipelines. And the appropriate place to insert those interception pipelines is inside our proxies. And what that means is we can actually extend the behavior of our functional components, our account manager, for instance, and handle things like automatic logging, runtime measurement, and logging of those metrics. We could inject if we were feeling really goofy, we could inject a validation interceptor into these things. So the validation no longer becomes part of the act of loading or creating our customer profile. We can run pre-flight checks before we even invoke our components method. And we're going to get into this validation concept next week. Because right now we're able to invoke our methods through the proxies. I think I want to add some automatic logging capabilities here. So up here in IFX, we're going to get some logging stuff going. And all this system model stuff should probably be moved out to less specific internal framework. But I want to get it fleshed out better first. And I'm just going to need to hack on some contrived code for a while, and I'm not going to do that on stream here. But my goal here is to get myself to a point where I can enforce those ontologies. Managers may call engines and resource access components. Engines may call resource access components. Resource access components may not call up the stack. Only clients can directly call managers. Stuff like that, those rules about our component taxonomy, those ontologies. I want to see about creating some interceptor objects that can maybe enforce those rules at runtime. I mean, we're not going to be able to create compiler errors from them, but we're certainly going to be able to throw exceptions at runtime if somebody tries to invoke a manager from a resource access component or go directly from the client to the database or what have you. And we're going to be able to have a manager in charge of instantiating its dependencies again. We might pass in the type name or tell it, I know you need this dependency. Here is where you can get a builder for it. I don't mind the idea of passing pointers to factory methods necessarily. I do mind fully configuring a dependency and passing it directly into the manager, because that means that manager is going to be able to, or some other manager that's not supposed to get my dependency is going to be able to instantiate it, and then all hell breaks loose. So the goal of all of this stuff is really to protect our closed architecture and make it easy for other developers who aren't as familiar with this style of architecture and design to do it the right way. I want to make it easier to do it the right way than it is to do it the wrong way. I've heard people refer to this as pushing folks into the pit of success. And I like that visualization. I'm a little bit more apocalyptic. I like launching people from the trebuchet of success. But that's just because it's a funny slapstick visual. So I'm going to play with this offline a little bit more and see if I can actually get it to go the way I feel like it should be going. And have yourselves a great, safe weekend. It's a big week in the United States next week. So, and a lot of people are feeling a lot of ways about what we're doing here in the U.S. next week. And regardless of which side you're on, I hope you come through the result of next week's activities unscathed, still healthy. Maybe maybe disappointed, maybe a little bit angry, but I hope the results of next week's stuff result in positive outcomes for everybody, regardless of who they are. That's all I'm going to say on the politics. Have a great, safe weekend. Take care of yourselves. And happy coding. Bye now.